Today, let us solve some problems. Okay. The first question: two spheres of masses 3 into 10 to the power of minus 3 kg and zero point 0.5 kg respectively, placed at a distance of 0.05 meter apart, attract each other with a force of 4 into 10 to the power of minus 11 Newton. Find the value of the gravitational constant. Very easy problem. Okay, two spheres of masses, one mass is given here m1, another mass is given m2. The distance between these two is also given in terms of meter. If this is not given in terms of kgs, you have to convert in the form of kgs. If it is given in terms of grams, convert them in the form of kg. If it is given in the form of centimeters here now, the distance between the two masses, that is also we are supposed to convert in the form of meter. Then we are supposed to substitute in the formula. Very easy problem. Okay, just you see that mass number 1 in terms of kg, mass number 2 in terms of kg, distance between the two masses 0.05 meter, the force of attraction between them is this much. How much is the universal gravitational constant? Okay, the formula F is equal to G into m1 into m2 divided by r square. So here I suppose to calculate capital G here, that is a gravitational constant. So capital G is equal to cross multiplication Fr square divided by m1 into m2. So substitute all these values. F, smaller value, distance between the two body masses, m1, one body mass, another body mass. So do this calculation properly using your calculator. So you are going to get this as the answer. Okay, the unit you are supposed to write. So just you can write here gravitational constant. Gravitational constant actual unit is Newton meter square per kg into kg, that is kg square. Newton meter square per kg into kg, that is kg square. So Newton meter square per kg square. If you don't know, just you can write SI units. Okay, problem number 2. Okay, calculate the centrifugal reaction exerted by a 2000 kg automobile while going around a curve of 150 meter radius at a velocity of 48 kilometer per hour. So the thing is, this is given in terms of kilometer per hour. First we have to convert this kilometer per hour in the form of meter per second. This is not in SI unit. 48 kilometer per hour we have to convert in the form of 40 so many meter per second. So kilometer we have to convert in the form of meter, and 1 hour it is equal to how many seconds, that you know, that divided by that number of seconds. Okay, mass is given 2000 kg, radius is given 150 meters, curve of radius, velocity is given 48 kilometer per hour, 48 kilometer divided by 1 hour. 1 kilometer is equal to 1000 meters, means 10 to the power of 3 meter. 1 hour is equal to 60 minutes. 1 minute is equal to 60 seconds. Therefore, 1 hour is equal to 3600 seconds. So divide this, you are going to get this amount of meter per second for the velocity. Now, we know that formula, centrifugal reactional force is given by mv square divided by r. So substitute these values. M is equal to this much, 2000. Okay, V is 13.333, that's square, and radius 150 meters. So just you divide and multiply this one, you are going to get the answer as 2369.18 Newton. Okay, let us go for the third problem now. There is a flywheel. Flywheel means a wheel which is rotating. Okay, a flywheel of mass 500 kg and 1 meter radius makes 600 revolutions per minute. Assuming that its mass is concentrated at the rim, not at the center, calculate its angular velocity. This is a question. So how we are supposed to solve? So the mass of the flywheel is given 500 kg and 1 meter radius, it has been given 1 meter radius. It is making per minute 600 revolutions, means it is rotating 600 rotations in 1 minute. Assuming that its mass is concentrated at the rim, calculate its angular velocity. How we are supposed to solve this problem? Okay, so let us solve that problem like this. You see here, number of revolutions per minute, 600 is given. Number of revolutions per second we have to calculate. This is per minute divided by 1. That 1 minute converted in the form of second is 60 seconds. Therefore, you are going to get number of revolutions per second is equal to 10. The formula, it says that angular velocity is equal to angle turned through what angle with which it has been turned divided by the time interval. The angle whatever it has been turned is equal to 2 pi n, because one rotation is equal to 2 pi radians. N number of rotations is equal to 2 pi into n total angle rotated. The time taken for that, it is equal to t. Therefore, it is 2 pi into number of revolutions per second is 10. Therefore, I will take this n is equal to 10 here divided by this 1 second. Therefore, you are going to get 20 pi radians per second, where pi is equal to 3.14, and hence you are going to get 62.8 radian per second. Okay, let us go to the fourth problem here. The fourth problem, it says that calculate the centripetal acceleration and the centripetal force on an electron moving in a circular orbit around a nucleus with a linear velocity of 5 into 10 to the power 6 meter per second. The radius of the orbit being 0.5 10 to the power minus 10 meter, and the mass of the electron is said to be taken as 9.1 10 to the power minus 31 kg. So the meaning, the mass of the electron is given, it is rotating around the nucleus. We are supposed to calculate its centripetal acceleration and also I think centripetal force, centripetal acceleration and centripetal force. How we are supposed to do it? So first idea, mass is given already. You are aware of how much is the mass of the electron. Mass of the electron is given. And the radius of the orbit, fortunately, it is not given in terms of angstrom. Directly, it is given in terms of meter. And don't forget, 10 to the power of minus 10 meter is equal to 1 angstrom. Actually, this is 0.5 angstrom. If they have given in the problem 0.5 angstrom, 1 angstrom is equal to 10 to the power of minus 10 meter. You have to convert all the things to SI unit, that is angstroms to meter. But fortunately, in this problem, meter is given. And it is moving with a linear velocity 5 into 10 to the power of 6 meter per second. Again, it is given in terms of meter per second, easy problem. If it is given in terms of centimeter per second, you have to convert in the form of meter per second, then you are supposed to substitute. Now, centripetal acceleration, we know that. The centripetal acceleration is equal to v square divided by r. So, v is given, that square, r is given, 0.5 10 to the power of minus 10 meter, that value it has been written, divide one by the other. By simplification, you are going to get 50 into 10 to the power 22 meter per second square, that is centripetal acceleration. Centripetal force is given by mass multiplied by acceleration. So mass is given already, 9.1 10 to the power of minus 31 kg multiplied by this acceleration. So therefore, if you are multiplying mass into, this is actually the PUC knowledge or maybe the high school level knowledge, F is equal to m into A. Centripetal force is equal to mass into acceleration. Multiply these two, you are going to get some value here now after calculation, simplification. So since it is a force here, you are supposed to write Newton. Okay, problem number 5. Question number 5. Now let us consider a body of mass 0.1 kg is whirled, means it is rotating round uniformly at the end of a string 1 meter long. So don't forget, it is 1 meter is given in terms of wordings, 1 meter long, revolving 60 times in a minute. So time interval is also given. Find the tension in the string. Find the tension in the string means how much is the centripetal force. How much is the, if a body is go on revolving like this, there must be a centripetal force. That is, that centripetal force itself is said to be taken as a tension. Now, again, go back to the problem. A body of mass 0.1 kg. Mass is given as 0.1 kg. It is revolving round uniformly at the end of a string which is 1 meter. Means the radius of that circular orbit in which the body is moving is equal to 1 meter. So therefore, I have taken the radius is equal to 1 meter here. The radius is 1 meter. Now I supposed to calculate the tension, but don't forget it is revolving 60 times in a minute. It is revolving 60 times in a minute, means angular velocity is given. Okay, 60 times means the total angle covered is equal to 2 pi into n. N is equal to 60. 2 pi into n. N is equal to 60 here. Divided by 1 minute. 1 minute means it is 60 seconds. So you are going to get 2 pi 60 divided by 60 per second. Therefore, 60 get cancelled. 2 pi per second. Pi value you can substitute as 3.14. Okay, so go for the centripetal force here. The centripetal force, now he has asked in terms of tension here, that is equal to mv square divided by r, that is also equal to m omega square into r. So here m v square divided by r in terms of linear velocity, m omega square into r in terms of angular velocity. So substitute mass is equal to this and omega is equal to this value, that square multiplied by radius. Radius is given directly as 1 meter. And if we are substituting all these things and doing the calculation, after simplification, we are going to get 3.943 Newton. Like this, we can change the numbers here and there, and we can give you the problem. And you are supposed to work it out properly with the concerned formula. The first and foremost thing while solving the problem is, first we have to read the problem. Carefully we have to read the problem. We have to understand the problem. 2 or 3 times we have to read the same problem, understand it, what it says. Then you are supposed to write like this. Okay, the data you are supposed to write in terms of symbols. Then once you have written the symbols wise the data, and you have to check it up before substitution whether all of them they are present in SI unit or not. CGS units you should not use it. You have to convert the CGS units in terms of SI system units, and then concerned formula you are supposed to write. Substitute all those things in the case of your formula. Then substitution is over. Then you have to do the calculation. Simplification is to be done properly. And once you got the answer, you have to think what is that SI unit we are supposed to write. If you don't write the SI unit, you are losing the mark. Okay. All the best. Okay. Study well.